Okay, so starting with some slope-intercept form, this is probably maybe the one thing from Algebra 1 that we come away like knowing y equals mx plus b, where b is your y-intercept, which we looked at a little bit yesterday. If you plug in x, that is 0 for x, that is what you're going to get, is whatever b is for the y-intercept. And then m is always the slope. Your x and y is every point that is on the line. So writing down whatever you need to there. If you're like, don't need to be reminded any of that, it's fine. And the other form that we will look at, I'll leave this here at the top, or if you're still writing things down, is point slope form. So our point slope form, both named very appropriately, has a point from the line and the slope. So if we don't know what the y-intercept is, but we have a point and the slope, then we can put it into point slope form, where your x1, y1 is one of the points on the line, and m is still the slope. This may be the one that we need to write down as far as maybe not remembering exactly what it looked like. What you may not have known is that point slope form is literally just the slope formula. If we were to divide both sides by this x minus x1, then it would just say that the slope equals this y minus y1 over x minus x1. So that is the slope formula, is subtracting the y's over subtracting the x's. Still, your x and y here are going to stay variables. That's going to represent every point that's on that line. And then there is a standard form as well, but we're not going to write it down. Very rarely are we asked to put something in standard form. It might start out that way, but it's not worth necessarily knowing because we're not going to be plugging things into it. We might have something in standard that we're trying to solve for y so that we have it in slope-intercept. A lot of times we'll be starting with point slope form and then maybe simplifying it to get to slope-intercept, maybe just leaving it in point slope form. Kind of depends what we're doing. Okay, so a few things with slope before we move on. There's a little bit of skew. You do not need to write these down unless you just feel like you need to. So the first one, our slope, is talking about the fraction what over what? Rise over run. Yes. What variable do we use for slope? Just look at it. M. Okay, this one, show me with your arms. Positive slope does what? Like with your hands. Okay, very good. Goes from down to up. Slope-intercept form we just looked at. Negative slope with your arms. It's going to go down from left to right. Anytime we're looking at a graph, we are reading it from left to right. So if we're talking about slope, positive, negative, that's from left to right. If we're talking about increasing, decreasing, constant, we'll get there eventually. That will be from left to right as well. Do we remember the slope of a vertical line? Like this. It is not 0. Okay, so this is how some people remember it, which there are several ways that we can go about looking at it. But one way to remember it is that you can ski up a slope. So if you're going up, I can ski up a slope. I can ski down a slope. I can ski on flat ground. It's just zero fun. If you've ever skied, that's not fun. So slope of a horizontal line is 0. If you're skiing on this, you are not skiing anymore. Now you are falling. So this is undefined. That is our undefined slope, which we'll look at a little bit more closely here in a minute. Your horizontal is going to be 0. And then whenever we're talking about a real world situation, this is, well, I'm not going to be this. In a real world situation, we're talking about the rate of change. Oh, not the rat, the rate of change. So if we're talking about, I don't know, speed, your speed is changing over time, then your slope is going to indicate how that speed, the rate that it changed over time. If you're looking at a bank account, it's going to be the rate that the money increased or decreased over time, but that slope is giving us the rate of change. Okay, so let's look at how do you find the slope if you have 2 points. We've got -1, -8, and 2, 1. We just looked at it. What is the formula to find the slope between 2 points?
Subtract the log.
So we've got our, and usually they put like y2 minus y1, x2 minus x1. But it is the rise over run. We're saying what is the difference between the y's, that would be your rise, and the difference between the x's would be your run, how it's changing horizontally. Does it matter which point is x1, y1, and which one is x2, y2? No, doesn't matter which one. It does matter that we start with the same point first both times, just like the distance formula. So if I start with my -8 for this y, and I would have my -8 minus 1, because I'm subtracting the y values, then I would have to go back to this first point for my first x. So I'd have the -1 minus 2. Which sometimes, you know, if it's on a graph, we're able to count rise over run. You don't necessarily have to use the formula every single time. We could plot these and count, but you're going to be counting quite a bit since the difference between the y's was 9. And then we always want to simplify. We'll get a +3. So this could have also looked like, if I started with the 2, 1, it would be a 1 minus -8. And then 2 minus a -1. So you'd end up with a +9 and a +3. Still end up with 3. Okay. So how would we interpret this on a graph? What is that 3 telling us? And go over 1, yeah. So remembering that anytime there's not something in that denominator, it's a 1. So go up 3 and over 1. Okay. So looking at horizontal and vertical lines a little bit closer, which you can sketch this if you want to. This vertical line goes through a -3. So what did we decide the slope is going to be? Undefined. Okay, so to look at that closer, so you could remember the skiing thing, that might help. But also, if you choose, say we just choose 2 random points. If I have the point, this is -3, 3, and -3, -2. It doesn't matter which 2 we choose. No matter which 2 we choose, our rise, or the difference between our y's, is going to be a number. So for these, my rise is 5. My run is always going to be 0. So this is why the slope is undefined, because it didn't run any. I can't divide by 0. I get undefined. The equation for this line comes from what all of these points end up doing. So we have got -3, 5. We could have a -3, -4. What do you notice? 0. They're all -3. So our equation is going to come from the fact that we have a constant either for x or y, depending on whether it's vertical or horizontal. So vertical, the x is going to stay the same. And so the equation of this line is x equals -3. That's the equation of the line. equation. So for any vertical line, and also we can't put it in that y equals mx plus b because the m is undefined. I can't plug in something that's not a number. Well, yeah. So same, similar. Do we have questions there? So vertical, it's going to be undefined. The equation will be in x equals, and then whatever that x is, that's consistent. Very similar for a horizontal line. So if you want to sketch it, this is just at 2. Horizontal line at 2. So for slope, if we wanted to investigate further, we could choose our 2 points. And now which part of our slope is going to be 0? Well, so how would I find the slope between these two? What would happen on the top? It would be 0. Yeah, you'd have your 2 minus 2. Remember, you're subtracting the y's over subtracting the x's. And it doesn't matter what that denominator ends up being. I could choose any 2 points, and so they could be different distances apart. But no matter what, 0 divided by a number is 0. It didn't rise at all, so that's why the slope is 0. If I'm writing an equation of the line, what do we notice is always going to be true? Yep. X is not always 2. Y is always 2, yeah. Our x's change, but the y is always the same. So this is a y equals 2. Or if you want to think about it in slope-intercept form, this one actually does work in slope-intercept form. It's just that the slope is 0. So it would be like a 0x plus 2, which we don't normally write it that way, but it's not incorrect. Okay. The last thing that I want to remind us of before we get to some practice are parallel lines and perpendicular lines. So do we remember what slopes look like if the lines are parallel? What do we know about the slopes? Yeah. Equal slopes. For sure. Do we remember what slopes look like for perpendicular lines? Yes, it is going to be flipped. Our fancy word for that is reciprocal. Okay, so slopes. They're going to be reciprocals. Do you remember what else has to be true? Yeah, what about the y-intercept? They have to be the same? No, they don't have to be the same. So that would mean that you are wanting it to cross at a specific point. We don't care where they cross at. It's just going to be perpendicular to it. They've got to be opposite signs. Very good. So usually we just say slopes are opposite reciprocals. But this just means different signs, that opposite part. So different signs, and then by reciprocal we're saying flipped. Okay, so we're writing the equation of the line that is perpendicular to 2y equals 4x minus 7 and goes through negative 6, 5. Okay, so first, if we're going to write a line, an equation that is perpendicular to this one, we need to figure out what the slope of this one is. So how do we figure out the slope of that 2y equals 4x minus 7? Yeah, we want to get that y by itself, because once I divide by 2, so I've got this 2x minus 7 halves. Once I divide by 2, now can I tell what the slope is?
Yes.
Yeah. So the slope is just going to be 2 of this one. Okay, but we're worried about the line that is perpendicular to this line. So if I am perpendicular, what will my slope be?
Negative 1/2.
Very good. So opposite sign and the reciprocal. What if the slope was a 3/2? Somebody else, what would the perpendicular slope be? So it would be negative. Oh, it's 3/2. There you go. So you have a negative 2/3. So just another example there. They've got to be opposite signs, and then they're going to be reciprocals of each other. For this, sometimes it helps to put it over 1. Okay. So we've got our slope is a negative 1/2 now, and then we also know that the point it goes through is negative 6/5. So now how do I write an equation with that information? I've got a slope and I've got a point. What type of equation do I want to put it into? Point slope. So I have a point and I have the slope appropriately named. I need point slope form. Okay, so we're remembering that y minus y1 equals our slope, x minus x1. So then we're just plugging in my y minus the y that I have is 5. I've got a slope of negative 1/2. And then I've got my x minus a negative 6, which would make me add 6. So depending on what we're doing, if we're wanting to put them into slope-intercept form, then I would go ahead and distribute my negative 1/2 and add my 5 over, get that y by itself. But there are a lot of cases where slope-intercept form is just fine, and we'll leave it. In calculus, a lot of times we write equations of lines frequently, actually, for tangent lines, and a lot of times we will leave it in point slope form. Really, this is like the calculus part. We have to figure out the slope or whatever, and then we're plugging it in. We just leave it like that. Do we have questions so far? Especially the parallel perpendicular? Okay, we just got about 5 minutes, so I'm changing up how we're going to do this because I thought we would have more time today, and we didn't. I think maybe I wasn't thinking about Friday's schedule. So if you would like to start the homework, you may, but it is not due until Tuesday. It is going to be on Delta Math, so over the weekend, if you want to get into it a little bit, you can. But Monday, we'll do like a Kahoot or something where we're practicing them together because we just didn't get into this that much. We'll practice it together, and then I'll give you some time to work on that. It won't be due until Tuesday. So let's just try a few more since we've got about 5 minutes. Let's go. We'll write a few equations. So write an equation that is parallel to, let's say, and goes through. Let's see if we understand that. Point slope form. Let's go ahead and put this in slope-intercept whenever you're done. So solve for y.
I'm confused.
Okay, so the first thing is to decide what your slope needs to be. So based on this guy, parallel to that line, what does our slope have to be? Mhm. So what is the slope of that line? No, I'm just looking at it, what part of that is the slope? So the mx plus b, so that's your y-intercept. This is the slope. Okay, so now that you have your slope, you know your slope, you know your point, you're putting it into this.
Okay.
Okay, so it looks like you perpendicular.
Oh,
But let's check. We'll just change your direction.
No.
Yeah, if we put in that well.
I was like, we didn't take a look for it. It's part of the feed, so.
Yours is quite a bit grosser than I intended. The other one's very subtracted too. Okay, so you're good for perpendicular, so I just change your direction. Good. Good on your slope. Okay, so this is the cut that it's going through. So the 5 won't be used. That's the y-intercept there, but you'd have your like y minus -2, and then here. That part's good. So just this part should be y minus
Would it change the plus two?
Yes.
And also the doesn't.
Mm-hmm.
Is there like a log or something?
Is there a what?
A vote login?
Mm-hmm. You got on it yesterday, didn't you? No. Or 2 days ago?
I don't think we did. I don't think we got to do that. Did we? I think you were gone for the.
Oh, you came in late. You came in late. It was the day that we were finishing the clue. Well, here for the folks at home, there's the answer for that one. So our slope was the same. So I'll get you set up here, Claire. The slope is the same since they're parallel, and then we're just putting it into point slope form. So we've got our y minus -2, and then our x minus 1, and then simplifying. There are different routes that you can take. I saw on Cody's. Used slope-intercept form instead. And that works as well. Once you have your slope, so we know our slope is 3, we can plug in our x and our y that we know, and then solve for b. That works as well. So you can solve for what that slope-intercept is, and you just have to re-plug it back in. Ring twice. So Claire, I will go